Yes, sir. You're good, sir.
Okay. A very good afternoon to everyone. On this beautiful late afternoon, we have gathered for a webinar titled Visual Processing Using Deep Neural Network, which will be presented by Dr. Maity. Dr. Satyabrata Maity is currently working as an associate professor in the Department of IT, Techno International Newtown, Kolkata, under Maulana Abdul Kalam Azad University of Technology. He has served 4 years at Shikha Nishanta Deemed to be University as an assistant professor during 2017 to 2021. He has completed his PhD and MTech from A.K. Chaudhary School of IT, University of Calcutta. He stood first class first in MTech and received DST Inspire Fellowship in his doctoral program. He has received GET Fellowship to complete MTech. His research interest includes computer vision, machine learning, and IoT. His PhD includes video summarization, background modeling and elimination, and human activity detection. He has published 25 research articles in different international journals and conferences. Now, I would like to request Dr. Maity to take the baton of the webinar. Dr. Maity, the stage is all yours.
Thank you so much for a nice introduction, Mr. Dotto. And I think Madhuri ma'am is also there. So, my dear students, let me allow to share my screen first. I hope my screen is visible to you, right?
Yes, sir. It's good, sir.
Fine.
Sir, is
And
it possible that we have your picture once with the
sure,
first
sure,
screen?
sure,
Like,
sure, 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 sure. Is it fine? Am
yes, sir.
I
It's good.
visible?
Yes, sir. Yes, sir. It's good.
Oh,
Thank you, sir.
okay, okay. Noises. So, okay. So, let's start the thing. So, I would like to lecture on visual processing using deep neural network. My introduction is already been done, so I am not going into the details of that. So, before going to the topic, I would like to tell you a few things. First, let's have a game. Can you please count the black dots in this image? Guys, I would like to be interactive, right? So, please, hello. Students, are you there? Hello. If you
Yes, sir.
just unmute your mic and interact with me, that would be better for me. Yes. Can you please count the black dots in this image?
So, if an answer, someone says 2, someone says 0.
Okay, okay, fine. So this is one, and next is, yeah. Do you see the squares in this image? Do you see the squares in the image? Students, if you can unmute your mic and interact with me, that would be better for me. Hello. I'm showing you again. This is the first one. Can you please count the black dots in this image? And second one is this. Can you see the squares in this image?
Yes, sir, we can.
Okay. So for the first one, see, actually there is no black dots, right? These all are absolute white, right? But with this optical illusion, we might see some black dots in it. And in the second image, all are squares. In between that, the background, inside the background, we are having all squares. But as those are aligned in different way, it might not see like squares, but it is these three are squares, absolutely. Okay, so These all are visual things, and every day our brain process the thing. Most of the input we are taking are visual inputs, right? So visual things are important to act something, and whatever the situations we are reacting, visual inputs are always important, right? And there comes the topic visual processing. Okay, so I'll try to go into another story, right? Prior to that, there are two things in the world. One is knowledge and another is intelligence, right? Knowledge is having the right answer, and intelligent is asking the right question, right? Now these two things are required, right? While we are taking some decisions, these two are very much required, knowledge and intelligence. Fine. Why knowledge is required? Because knowledge are the interpretations or of several things, what to do in what conditions, right? But we are having knowledge, not having that much intelligence, then we will be in trouble. Clear? Intelligence will make you clear about the situations, right? Like one thing we have used time and again, right? Common sense, right? Common sense are driven by intelligence. If you are having more intelligence, then you can overcome the situations whatever it may be in quick time. And if you are not having intelligence, whatever the knowledge you are having, you can apply that while it is most required, right? That's why, from the words of Albert Einstein, the true sign of intelligence is not knowledge but imagination, right? Knowledge is one thing, but how we can utilize that knowledge, that is much more important. Okay, now there is a story, and I think you all are knowing about this story, right? Can anyone please volunteer me about this story? From this image, what story is coming to your mind? Hello students, are you there?
Can I answer, sir?
Sure, ma'am. Please.
Oh God, no, I think I'm wrong, sir. I thought there was a lion. This is a bear, so I have a wrong story.
Okay.
I have to.
Okay. Actually, in very childhood days, maybe we are having the story from our grandpa or grandma. So this is a folk tales, right? Two friends are walking through a jungle, and uh, suddenly one bear coming towards them, right? And out of those two friends, one is knowing how to now, while the other friend is there, he's thinking and trying to coming out of the situations, right? And suddenly it came to his mind that bear is not taking the or not attack the dead people, right? So he lay down on the street, right? Like a dead person, and that saved him, right? After different check, bear has passing through, and then the other friend is coming down from the tree and asked him that what bear said to you, right? And then the story is something else, but that moral of the story was, in that folktales, was the friend in need, the friend in need is a friend indeed. But here I am just trying to show this story to tell you about the intelligence, right? Those who are having the knowledge or having the experience, they can survive with their knowledge, right? But if you are having intelligence, you can also survive, right? So in this way, they are having their own intelligence, right? Okay. Now, this is one of the man whom I admire most, right? So this is the story of Alan Turing. I hope you all are knowing his name, right? He is a father of computer science, right? Theory of computer science, some people are telling like that. And there is a I mean, think the award like the Nobel in the field of computer science with his name, Turing award. And this is the machine which can uh, have you heard of the name Enigma? Anyone?
Yes, sir.
So this machine can use to break that, right? So this is the thing which is quite related to the Second World War. At that time, Germans are using some crypted language to send the message to their soldiers or generals, and this machine was used to broke that cryptic sequence, right? So in that way it was used, right? I am again showing this to relate how much these things are, this machine intelligence and other things are related, right? I think you have got a glimpse why these things are required, right? Now I am directly coming to the thing of visual thinking, why the visual things are required and how visual things are interpreted in computer science, right? So these are the different input things, right, which are mainly processed in the brain, and we are uh, taking care of different situations accordingly, right? So mostly we are having some sensing organs. These sensing organs gives us the input, and we act accordingly according to the situations, right? So there are mainly five: skin, eyes, ears, nose, and tongue. Okay, skin is helping us to take the input like touch, pressure, temperature. Eyes are helping us to take the light and different visual inputs. Ears are helping us to take the sounds and balance. Nose can sense the smell, and tongue is helping us to take the tastes, right? And these all organs are helping us to come over the situations, right? But most of the inputs we are taking through the input organ, which is called the eyes, right? That's why eyes and visual inputs are important, right? Now, this is the physical phenomenon, and everybody who has completed +2 of science is knowing this. The object, on the object, light is reflected, and it is or an image being created in the back of our eyes through the lens, which is there in the eye, and that is been transferred to the brain, and we see accordingly, right? This is the physics behind the visual inputs. Okay, now what we see and how it been seen, right? If we are replacing these things, that means this physical thing in machinery, then what it would be? So it would be like there is some illumination, that means light source, which is reflected on different objects, right? And that light is passing through a sensor, right, in the form of camera is there, and camera is sensing this whole things, right? And then in the back of this there are some machinery devices which is storing these lights, and if this camera is black and white, then the image reflection is quite like this. Okay, this is what we are taking it from, or through digital camera, right? Clear? Digital camera or any other camera. Clear? Now exactly what is been stored in the computer, if you just take this part of the image, right, this is nothing but a bunch of numerical values. These numerical values are stored in computer, right? Understood? So you can think it as a form of a matrix which is stored in the back of the computer memory, and there are some softwares which can interpret them in different forms, and we can visualize different things, right? So what is there exactly in case of black and white image? There are a combination of different values from 0 to 255. All the pixels and these values, these intensity values, or you can say these digital values, which is of 8 bit, as it is 8 bit, you can say it is from 0 to 255, right? Why? Because 2 to the power 0 is 1 and 2 to the power 8 is 256, right? Clear? And if we represent it in computer or from 0 to the values of 8 bits long, then we will get 0 to 255, and this levels is called gray levels. Okay, and here you can see the value which having closer to 255, those are quite whitish. Those are in between, you can have some gray levels out of that, and those are close to 0 or 0 levels, those are quite black, right? So this range is from 0, which is representing black, and 255 is representing white, and in the middle of this range is representing the grays. Okay, so in this way the image is stored in computer, because this computer or computing device is only functioning if you are giving some mathematical values or numerical values, right? Without numerics, it's quite impossible to work in computer. Whatever the things you have included or you are storing in computer, no? Everything is in the form of some numerical values, right? Now you can have different capacity, right? That is depending upon the data type or size of the data type, you can say, right? Other than that, everything is numerics, right? Whether it be a audio, whether it be a video, whether it be a text, whether it be a animations, everything are stored in computer in the form of just numerical values. Understood? Guys, is it good to go? Fine, everyone? So visual processing is coming when we are having the value in numerics. If there is no numerics, you can't process. Now, how computer is converting that to numerics, that is depending upon this, right? This is the phenomenon of that, right? So from the object to these numerical values, you can understand the fact, right? Is it fine? Hello?
Okay, sir.
Okay, fine. Now, see, in case of color image, right, there is an extension, right? In case of grayscale image, it is only 0 to 255, but in case of color image, we are using 3 different channels, right? Red, green and blue. Why red, green and blue? Because red, green, blue are called the primary colors. Why these are called primary colors? Because with the help of red, green and blue, we can form any other colors, right? So to represent the other colors, we are using different combination of this red, green and blue. That's why these are called the primary colors. And if you take the highest amount of red, that is, and again, these all red, green, blue are taken as 8 bits values, right? 8 plus 8 plus 8, that is again 255. Sorry, 255, 0 to 255 for red, 0 to 255 for green, 0 to 255 for blue, right? Now, if you take 255 of red, 255 of green, and 255 of blue, then these 3 combinations can make you the color white. And if you take 0 of red, 0 of blue, and 0 of green, then it will get you the value black. And other combinations are different color combinations. Okay. So in this way, we can get other colors. And that's why we are using these 3 basic colors or these 3 different channels to represent the color images. And color image can get you feel of natural images, right? Which you can perceive in the real world. That image you can see through the camera through this RGB channels, right? So this is an example of this. This is an image, and we are using the color camera, we are capturing it, and in the digital systems we are storing it. Then it can be again reproduced in the form of colors, right? That is the beauty of this RGB system. Okay, fine. So now we are knowing two things: how it is, or how the natural world things are stored in the form of digital values, right? That's the first thing. And second thing is how the color things is been included, right? So these two things has been done till now, right? Is it good, everyone? Hello?
Sir, yes, sir.
Okay, okay, fine. So in the real world, actually, uh, image or text or audio, whatever we are taking, right, we have to take the knowledge out of it, right? So there are two things we can say: image and descriptions. Image is the visuals and description is the knowledge out of it, right? Say for example, if you are just visualizing an image of a car, the description is something. When you are visualizing the same of a bird, then your description would be different, right? So these descriptions are nothing but the interpretations, or you can say the scientific interpretations of those objects you are visualizing, right? So there are two forms: image and descriptions, and image and descriptions. If image is the input, right, image is the input and image is the output, that particular things is called digital image processing, right? We are taking, right, input as image and we are reproducing it in different domain of the image, right? So that is called digital image processing. If you are taking input as image and described it in form of knowledge, then it is called computer vision, right? If you are taking description as image, taking input as description and output as an image, that is called computer graphics, right? You can say computer vision and computer graphics are two different ways which are reversely proportional or reversely related, right? In computer vision we are taking image and describe it, and in computer graphics we are taking description and giving out the image, right? Say for example, draw a circle, then using computer graphics you can draw a circle, right? Draw a circle with color red, foreground color is this and background color is this, and you are describing this, or you are drawing that. So that is computer vision, computer graphics. And computer vision means you are taking an image and you are trying to see that how many people are there, can you detect a face? So image is there, then description is yes, there are 10 faces, right? So these particular things is called computer vision. You are taking input as an image and you are giving the description or giving the knowledge out of it, extracting the knowledge out of it. That is computer vision. And if you are having a description, right, as input and giving out the description as output, input is description and output is description, that is called artificial intelligence, right? You are taking some description and out of that you are providing the world, right, with some answers. That is again in the form of description, that is called artificial intelligence. I think you have understood the connections between these many subjects which are related to this particular things which is called vision processing, right? Okay, now there are, now if you are trying to understand different form of computer vision or computer vision processing, then in the middle of it there must be a knowledge base, right? After that we can say what are the other things which is related to this. First is image acquisition, right? Image acquisition means there are several devices which are helping us to store the image, to take the images, right? You can say one of the acquisition devices camera, and through us acquisition device is our eyes, right? And we are using the acquisition devices according to different problem domains, right? Clear? The things, maybe in some cases we are using CCD camera. CCD camera means charge coupled device. It is totally used color sensor, right? And you can use, in some cases we are using infrared sensor, thermal sensor, sonar sensors, right? For SAR imaging, right? Satellite aerial imaging, we are using that kind of sensor. So different sensor are used for different purpose. Okay, that is depending upon the problem domain. Then after getting the images, what we are doing, we are trying to enhance the image. There are different procedure which enhance the image quality, right? What is the image quality? Image quality means, say for example, you have captured some images which is not visualized properly. If it is there such kind, right, then we are using certain kind of noise removal algorithm to get some better image. Clear? Now in the other sense, what I can tell you is, say for example, same image, same area, same capturing device can capture the image in different time of day, the image quality would be different. So there is an effect of light, effect of illumination in every time while you are capturing image, right? But for our brain, if you stand there and for different time of the day you are being captured, our brain can understand easily. Clear? But right, while it's a acquisition device and a computer is doing that, then you have to use some intelligent algorithm to understand those three people are same, right? So if there is an algorithm which is used to neutralize this illumination thing, right, then that can be easier to us to process further, right? In that way we are using image enhancement techniques, right? There are some techniques which is called image restorations. What is that? Image restorations means, say for example, there is some distorted part which is totally distorted in some image. If you want to restore it in the previous form, there are some intelligent algorithm, right, which can help you to restore it, right? And as you see, color is one of the important concept in image processing. That's why color image processing is one of the domain. Wavelets and multi-resolution processing is another domain. And you know the quality is directly proportional to the size of the images. If you increase the size, right, and as you use in your daily life using your mobile phone, there are different size of the images depending upon different camera qualities, right? Sometimes we are call image of 5 megapixels, 10 megapixels, 20 megapixels. These all are nothing but the size of the image which is increased, right, to increase the quality of the images, right? But if you want to store these images in uncompressed way, right, it will take more areas, right? So in that case, we are using image compression to reduce the size, because most of the value used in the images are redundant. And in compressions, we can moving out this redundancy, right? And you know there are several methods to moving out these redundancies, right? So image compression is another area. There are two things mainly connected to this image compression. One is called lossy, another is called lossless. Most of the time we are trying to have lossless compression, right? Right? But but in the real world things, most of the time we are using the procedure which is lossy. Can you tell me one of the image compression technique? Every day you are using different images and there are some types of the image. Can anyone please tell me one of the image compression techniques? Yes, yes. Can you tell me the full form of this? Anyway, not required. JPG, PNG, BMP, TIFF, these all are different image techniques, right? These are the extension of images, different types of the images, and everyone is using its own compression techniques, right? JPG is using not one technique, they are using many techniques to compress the images, right? Clear. Latest way they are using to compress is wavelet, right? Now there is another field of image processing which is called morphological processing, right? If there is some distorted boundaries, right, and other things, you can make it up with this morphological processing. Another area of image processing is called image segmentation. These all are technical: image segmentation, representation and description, right? Object recognition. These all are the high-level part of image processing, right? How we are interpreting the things and how computer can extract the knowledge and store it. Those all are related to these areas, right? So this is overview of different image processing domains, right? If you want to work on, these are really be helpful for you, right? Now, uh, actually, for each of the areas, if you want to fit any of the image processing task, right? First thing you need to have, or you need to understand the problem domain, right? If you can understand the problem domain and you can formulate the problem clearly, then you can work on, right? In image processing domain, these are the basic steps towards any of the image processing techniques, right? First is there is some image acquisition devices through which we are trying to extract the you are trying to capture the images of the domain which is related to the problem, right? Then we are using some pre-processing techniques to make the image better, right? Clear. Then we are trying to segment the image, right? Because I am just giving you an example so that it would be more clearer. Say for example, you want to capture you want to make your home secure. To make your home secure, what you did, you just put a camera in front of your door, right? Clear. Now in front of door there is a camera. Now if someone is pressing your key bell, right, or doorbell, clear. So at that time the visuals of that particular person will be taken out, right? Then it is informing you who is there outside your door. Clear. So this is the thing. Clear. And according to that, if actually what I did to solve this problem, what we can do is we have to put a camera in front of my door, and that camera will take the image, right, and send it to my computer. Now in my computer, first we are pre-processing it. Pre-processing can be of many types. What we can do, we can if there is some noises, if there are some problem in the image, we are using some denoising techniques to make the quality of the image better. So we did it first in the pre-processing things, then we are segmentized it. Segmenting in the image, in with your face there are some other information, right? All the things are captured by your camera, isn't it? So these all things which is apart from your face is not required. Clear. So segmentation things, what it can do is it's that segmentize two things, which one is face, or you can say the foreground, and it is eliminating the background, right? Now only the face things is stored. Now there is a knowledge base, right? Knowledge base can store the predefined face images, right? The all the members of your home and relatives, maybe. So you are putting 20-25 people's information in your knowledge base, right? Now this from the segmented images, it is representing, it can store in the knowledge base, or it is representing, or it is extracting some features, right? And that feature is comprising to the features of the different people which are stored in the knowledge base. Clear? Now it is interpreting or recognizing the things whether the people outside your door, clear, is known to your database or not. If it is known to your database, it is telling that, say for example, Sam is there outside your door, right? Whether I can open the door. If you tell yes, then the door will open automatically. If it is a voice based, fine. Otherwise it would not open. If some unknown people is there, then it can tell you some unknown faces is there, you please come and check whether I can enter your door or I can open your door or not. So this is a simple system, but we can utilize the computer vision in it to make it much better. Clear? Is it good? Hello? Can I move forward?
Yeah, fine, sir.
Okay, okay. Now, this is just an, I mean, you can say the description or you can say what digital image is. And we already have described what digital image and what are the parts of digital image. Mostly, a digital image is a collection of pixels, right? And these pixels are nothing but the impression of different color value, right? Which is reflected in your sensor. So everywhere we are using sensors, right? And why digital image processing is required, that already we have understood, right? Fine. Now, okay, I am just keeping these things up. These are the different areas where you can feed these things, digital images and different kind of digital images like this. Now, okay, fine. This, okay, fine. This intensity image, indexed image, RGB image, we have already discussed about two things. Grayscale image and RGB image, those are fine. Other things are required if you want to go much deeper. Otherwise, it's fine like this. Is there any queries from any guys? Yes? No? Fine. Now, before going to the last part, actually, this session includes two things, right? First one is visual things or visual inputs, and second thing is deep learning, right? As I came to know that most of the people are from fourth semester, I do not like to go deeper in deep learning part, but I can tell you where from these things are coming, right? Machine learning, deep learning, or the things of algorithm we are using, right? How these things are related to each other, right? That would be unfolded over here, right? But if you want to go beyond it, then you can contact me up anytime, right? So the main thing is, in traditional world, we are solving problems with algorithms, right? And data structures. Clear? Now algorithms are implemented with different programming languages, right? With the help of data structure. Isn't it? Everybody agreed with me in that sense, right? Some problem is given like uh, find the area of a triangle, right? This is the problem. Then you are using an algorithm, right, with some data structure. Clear? Then you will get the solution. And if you get the solution, then for every set of points or every set of 3 points, if that is a triangle, right, then you can find the area of that. Isn't it? Say for example, you can solve another problem like uh, shortest path. There are some cities, right? And you are given source and destination. You can find the shortest path between two cities, right? Using maybe Dijkstra algorithm, right? Using the data structure Q, you can solve this problem. So for any given cities that adjacency list, if the problem is given like this, and if you are having on adjacency list and you tell this is the source and destination, then you can have the solution. So you can have the right path. Yes or no? In traditional computing system, we are trying to get the solution like this, right? Problem is given, we are having some mathematical logic, right, in the form of an algorithm, and that algorithm is using two things, data structure, and data structure are mostly used in two different areas. One is input data structure, another is output data structure, right? Now we are implementing that algorithm in some programming language, and that will give us the solution for this particular problem. Okay, in traditional computing systems or using the programs, we are solving the problem like this. But right, can we solve every bit of problem in this traditional way? Right, I am giving you a problem to solve. Write a computer program to predict the good students in the class. Right, class is missed out somehow. Anyway, so predict the good students in the class. Can you write a program for this? Yes, you can write a program. How you can write a program? You have to know the parameters of good students. Maybe in this particular semester, you have been teaching 3-4 subjects or 5 subjects, right? And in different point of examinations, right, we are scoring different marks, and we are giving the output that who is scoring good marks, they are good students, right? You can solve it like that, yes or no? But if you want to solve it like that, you will be in trouble, right? Say for example, you set a marks, you set a threshold that if a student get more than 70%, then he is a good student, right? Clear? Now maybe in your class, every students got marks more than 70% or more than 80%, right? Or every people, any of the people is not qualified that 70% marks, right? In some difficult questions, maybe none of the students are qualified 70% criteria. Then you can say that no, none of the students are good, right? So it's not only the marks, there are some other things which are included, right? Clear? So every time you can change of different parameters, and if you change the parameters, your program will not work, right? I'm giving you another example, right? Write a program to find the hot summer day, right? As of the people of India, if there is a temperature beyond 15 degree to 20 degree, they can call it a hot summer day. But 15 to 20 degree is a winter of our country. It's a cold day, right? So definition is changing according to the situation, right? So if you want to write a program, again you will face some difficulties out of it, isn't it? Right? Then how can we solve such problems, right? If the problems are like this, then how can we solve it, right? Clear? How can we solve it? So these are giving us difficulties, right? Clear? What's next? Now comes, right? Actually, what we are taking, see, everywhere, whatever the decisions we are taking, that is really depending upon these things, which is called environment, right? And who are there in the environment and who have to interact with this environment, those are called agents, right? Clear? Now agents are sensing the environments or taking the input from the environment, and it is acting accordingly, right? If it is, say for example, you are the agent, or you want to survive, right? So in hot summer day, you want to use air cooler, air conditioner, or fan, something like that, right? In cold days, you want to use some warm clothes, right? Maybe room heater like of stuff. So according to the environment, you are sensing the environment through your sensing devices like those sensors as we talked of in the beginning, right? We are taking those things, clear, and then we are processing in our brain and we are acting accordingly, right? So from the environment you are taking the states, right, and acting accordingly, right? This is the main things. And if you want to implement this in computer, how can you do this, right? So this is the things, right? Traditional programming. And yes, in case of machine learning, what we are doing actually, we are taking data as well as output, right? And we are feeding these two things in the computer, and computer, this computer, whatever the, and we have prescribed some mathematical way to extract some rule base, which are taking data and output as input, both the data and output are like data, like say for example human, right, taking the temperature, and output is whether it is mentioning that hot or cold, right? These outputs are there, or good or bad, right? So for every student's data we are taking the marks, and we are taking the output from the teacher whether it is good or bad, right? And accordingly, for different sessions we can tell it, and accordingly we are setting the rule base, and we can tell, right, whether that students, or which students are good and which students are not good, not up to the mark, average, based, or I mean poor quality. So everything we can decide. So here in the computer, in the case of machine learning, we give both data and output as input to the computer, then computer is proposing some rule base. So this is the difference. And here the system is okay, there are many things. It's only looking like this. First is input past data, clear, and these data are having all the inputs as well as the output levels, right? We are training it to the machine, or to through some algorithm. Then this algorithm, this machine, after an adequate number of test samples, if you want to train it, if it has been trained, then it can have some logical models as output. Now we'll use these logical models for some other data to get some output, clear? And this is called the machine which is already been learned, clear? So this part of the work is called training part, where we are building the models, and this part is called the testing part. Well, we are using the models with new data to get the output, clear? Clear? So in this way machine learning algorithms are being utilized, right? And machine learning algorithms will performing according to the data and the capability of the different rule base, right? Clear? So these two things are important. Input data is also one of the important things, and second thing is the what mathematical logic you are using to solve this particular problem, right? Clear? If say for example you have used a huge uh, algorithm, but data is shortage, then also your machine learning algorithm cannot work better. And in other case, say for example you are using huge amount of data, but your algorithmic logic is not good, then it can perform worst, right? So performance is depending upon how many data you have given as input, as well as the mathematical logic you are using to solve the problem, right? There are numerous techniques to do this, right? But main thing is you have to build a model, and that model will used in testing cases, right? Clear? Is it good, everyone? Can I move forward?
Yes, yes, sir.
Yes,
Okay.
sir.
Okay. So this is the machine learning thing. And now, okay, so again, the example is quite similar. Training data, then out of training data, actually, all the data are not used for training. We are using certain part of it. Those are called features, right? Say, for example, if you want to remember certain person, right? You are not remembering each and every part of its body, right? Rather, you can remember his face only to remember him, right? So face is having two eyes, nose, I mean lips, your forehead, cheeks. So these are the features, main features, right? For a student, every day he is working, right? Every day he is studying, but the features depending upon the results, right? There are four internal exams, say for example, and one final exams. So this marks is defining the uh, features of this particular students, right? So features means not the whole data, the principal points or the main points extracted from this data are called features, right? Which is very lower in size, right? And we are using these features to train with some algorithm. Then that there we are getting the model. So for the testing cases also, for testing samples, we are again, right, for the test data again we have to extract this feature, then we are using this model to predict, right? So this is the two phases of learning and inferences. These are the two phases of machine learning model. First phase is called learning phases, and second phase is called inference phases, right? Learning phases and inference phases. So learning phases is mostly called the training, and inference phase is mostly called the testing, right? So there are mainly three different way to uh, implement the things in machine learning. One is called supervised learning, another is called unsupervised learning, and third one is called reinforcement learning, right? In case of supervised learning, we are having, right, we are having all the classes we are using, right? Those are predefined, and every data is coming with these levels, right? In case of unsupervised learning, the data are coming without levels, right? Reinforcement learning, if you want to freeze this model after training, this is one case. Another case, in case of testing, we may have some new kind of data which is not been tested before, right? Clear? Say for example, as we are trying to extract that hot summer day, maybe we have taken the data from Asia, data from Europe, but we have not considered the data from Africa, right? So if the data from Africa will come in case of testing, so there will be some problem, right? But when we are taking this new kind of data, we can take them in the training model. So model can train in the time of testing also, right? These particular things is called reinforcement learning, right? So learning is reinforced on the time of test again, right? Clear? So this is the other case of learning. I am not getting into the details of this as the time constraint is there, right? Now there is another thing which is very much connected to this machine learning things. Machine learning model are being uh, formed using or using the concept of neural network, right? As the concept of neural network is been taken, that's why it is called artificial neural network. Here you see inputs are there. In the inputs we are taking the features, and there are some layers. This is input layers, this is hidden layer, this is output layers, right? And each and every inputs are connected to these internal nodes, right? We can have more than one hidden layer also. Clear? It is quite like, right, the biological neuron what is there in our body, right? If you are been bitten, or some mosquito is biting on your screen, right, then the information is coming, right, through this axon terminals, then it is, right, forwarding the message to this neuron nucleus, right? Then it will again transfer the message to the next neuron, and the next neuron will send the or transfer the message to the next neuron. In this way, the message is reaching to the brain, right? Clear? Likewise, here also we are having some inputs, and there are some hidden layers, right? And that through that hidden layers, the things will be passing through, and each and every cell can process something, right? And according to that value, it is been activated, right? And it can send the information to the next level or not. Clear? In this way, the things are working sometimes, right? And that is called artificial neural network, right? And these layers are very, when you are having 2 3 layers, those are called shallow layers, right? Clear? Clear? And when we are increasing the layers in between layers, then that can purify the things in more extensive way, right? And there we called deep learning, deep neural network, right? And while we are using this computer vision processing, right? See, if you are thinking of an image, right? This image is of size, say for example, 250 cross 250, right? Total number of pixels would be huge. These many pixels can't be processes. That's why we are using some method which is called convolution, and another method which is called pooling. Convolution is extracting the features in each and every area of the image, right? It is calling through the image or scanning through the image and trying to extract the features. And number of features is pulled out in the pooling layer, right? How many uh, number of features we can pulled out in the pooling layer, that many reduction is been done, right? So in this way, repetitively using convolution and pooling layer, we are trying to reduce the size of the feature set of this particular image. If you are thinking of the pixels, each and every pixels are the informations contents in the image, then those 256 cross 256 pixels, it is having a huge size. After repetitive use of convolution and pooling, we can have minimum size of these particular features, and that it been flattened and use a neural network like this, right? That layer is called flattened layer or fully connected layer. Clear? So that is the whole idea behind this deep neural network, right? Why it is deep? Because to extract the features, we are using some in between layers. That is increasing the depth of the processing, right? Depth of this neural network. Clear? And ultimately, we are extracting the features out of it. And as it is human inspired processing, sometimes it can incorporate human like a response. Here, the way human is responding in the real world, this deep neural networks sometimes is acting like that. That's why it is very nice to use, right? Clear? And there are many deep neural networks, right? Like I can show you which are used in computer visions, like Google Net, ResNet, right? AlexNet, here Inception Net, here Mobile Net. One of the popular thing you might use, that is YOLO, you only look once, right? AlphaPose. So there are plenty of such things is there in the literature, right? If you want to go beyond this, and there are many tools nowadays very much available which can help you to implement this deep learning, which are called uh, you can use the tools like Google Colab, which can give you the support of Python. There are different Python library, right? One of the most popular library is TensorFlow and Keras. I think, right? You know NumPy, right? Pandas. So these all are all matplotlib. This all can help you to implement this, and there are very simple codes, right, which you can implement to test this kind of deep neural network in the field of image and video processing, right? Those you can do those short or small projects on this, right? That can help you, right? And there are certain device which is called Raspberry Pi. I think you are knowing it. Raspberry Pi is very much enabled with this Python programming, right? Now you can use Python programming, right, to check whether this can be face enable things or not, right? With Raspberry Pi you can solve it. The project costs at most or as much as 7 to 8 thousand, right? Clear? So you can test it. Clear? So one of the main thing is feature extraction, and I have told you what are the features mainly, right? So huge size of input image, very difficult to process. That's why we are trying to reduce it. So in case of taking all the things or all the pixels, we are dividing it small boxes, and from each boxes we are taking some extracting some features, and those are quite like this. And this feature is been after this feature is been tested or been used to classify these images, right? So image classification, this is one of the algorithm of image classification. Fine. This is the example of face recognitions, right? So this is they are using small devices to do this, right? Okay, fine. So nowadays I am in the my research interest has already been discussed, right? Human activity detection using deep learning, elderly monitoring system, IoT based home automation and surveillance, online video surveillance, students engagement detection in e-learning platform, IoT based health assistance. So these are the few of my research areas now active in my college, right? My college, and I am working with few students in Calcutta University. So in these two areas I am working, and if you want to work or work some of these fields, then you can ping me up anytime, right? Now I am open for the questions. I think we are in time. Yeah. So now I am open for the questions. So guys, if you're having any questions, you can freely ask to me. Yeah.
Sir, we will have your PPT, right? Because sometimes, I mean, already one student has pinged me that he wanted the PPT, and I think he would like to connect to
No,
you.
no issues,
So
no
can
issues, no
we?
issues, no issues, no issues.
I think he's a
Uh,
PhD scholar, so
okay. I'll share it with the Protik, so you can collect it from Protik.
thank you, sir.
Yeah. So anything else, guys? I want to. I mean, I'm very much interested because this is my institute just 1.5 year back, and I'm knowing each and every bit of it, right? And there is many students who are working with me. I don't know you are knowing their names or not. One is that Roy. What is the name? And now I think 4th year students like Saurabh, Bera, Gyana Ranjan, those are in touch with me, and they are worked well with me, right? So there are many people, and the environment is quite good. There are many laboratories, and as I know, one of the laboratories I have set up that HPC based lab, right? Multidisciplinary lab. So you can use these facilities to test these deep learning things, right? Okay, guys.
Certainly, sir.
If you are not having any queries, then we can. Okay, ma'am. Proceed with the things. Thank you very much for your attention.
I think Pratik sir got disconnected. On behalf of him, I would like to request Swagatika ma'am, if you are there, would you please like to give the vote of thanks?
Yes, ma'am. On behalf of Department of CSE ITER, I extend our heartiest thanks to Dr. Satyabrata Maity for delivering such a simple yet elegant talk from his busy schedule. Thank you so much, sir. The webinar was very interesting. I would also like to thank the organizing team of Computer Science and Engineering. I would like to thank Dr. Pratik Datta for inviting Dr. Maity. Last but not the least, thank you everyone for your patience and joining this webinar. Thank you.
Thank you very much, ma'am. Thanks a lot.
Thank you, sir.
Thank you, sir.
Okay, so I'm leaving.
Yes, sir.
Thank
Thank
you
you,
very
sir.
much. Yeah.
So we'll be in touch, sir.
Okay, ma'am. Okay.
Thank you, sir.